Hi class. So my name is Prem Asim Jain, and today we will be learning about the hashing, how hashing works throughout across software industry and especially how it works in Java. So, so before we start, let's try to understand the problem, why the hashing came first, as a solution, and then how people have implemented it or using it in Java. So just imagine that you are in a college and you have 1000 students. Now, if you will put all the students in one room, one big room, it becomes difficult to find out the people there. And let's say there is some person with name Zainab. So you have to go and check every person. Hey, are you Zainab? Are you Zainab? And then you might end up in 500 after talking to 500 people or 700. If you are lucky, maybe the first person is Zainab, or it could be the worst case, a thousandth person. So iteration, you have to talk to each and every. Hey, are you Zainab? Are you Zainab? ZANIB, right? So then people or engineers with the sharp brain thought, let's try to compartmentalize and group people somehow so that they are easier to operate, easier to manage, easier to find, and everything. So they said, okay, let's try to put them in buckets. So what they did is, instead of having 1000 people, they said, let's make sections or classes. So now they have section A, section B, section C kind of, and each section might have 100 students. So what happened now that there are 100 people in particular section, and then when you divide section, you have to have a criteria, because randomly if you will put anybody in for example section A, so you are putting anybody in section A and then anyone without any proper decided criteria in section B. So the problem will remain same. You have to go to each section and say, hey, is Zanib there, is Zanib there? Then it's not a problem, it's a problem again. So what do you do, that you divide them. Hey, whosoever has starting name from A will go in section A. Same with whosoever has name with B will go in section B. Now if someone says, can you please call up Zanib, principal is calling Zanib, so you will, now it's no brainer, you just have to go to the section Z, and probably there would be bunch of kids, could be 10 kids or 15 kids, because that is not very common alphabet to start. So you just need to first, you have to, by using some pointer or some mechanism, go to section Z, and then probably ask, it could be the first person or it could be worst case scenario 15th. So in software industry we take the happy path and the worst case scenario. These are two things. So worst case only 15 iteration, so things become really really fast and really really cool. So this is how we are optimizing the performance. We are not looping and all that. Now why I have just taken an example of 1000 people, but you imagine, let's say your CPS or your driver's license or whatever. So there are so many people who are in Texas, they have license, and if you not do not optimize, then performance would be a killer. On the UI, if you will try to do some query, if the data is not properly organized, if it is not properly hashed, then it might take forever to retrieve data. It will end up hanging your UI. You might get 404, 401, 500, whatever different error codes. That is why hashing come. So with this analogy, real life example, we already understood the what is the motive of getting hashing. Now how do we implement it really? So in this example we have 7 buckets which starts from 0 to 6. Now in each bucket what they did, they have different data basically. So data has a key value next when they are iterating. Just take an example of, this is a student which has a name and a roll number, and you are grouping them. So whosoever, whatever students whose name starts with B, you can put them in the B bucket. A is for 0 for example, B is for 1, and all these guys are there. So technically if you don't have this system, you have to iterate each and each, compare each time with the name, and then you will end up iterating more. In this case, you will just go to the index here, and whatever people are there, you will just try to grab them, and your things would be easy and simple. Now coming back, how it is implemented in Java. How to implement. You know the concept, and if you know the concept, you can implement it in Node.js or whatever, even in HTML. HTML is not a very good example to take because it has very less capabilities. HTML5 is having some capabilities of doing some calculations and some inbuilt functions like date and locations and so many things. But any programming language, you can implement this. So we'll try to implement it in Java, and then we will first try to see the hashing stuff. So let's get back to our stuff here. So hash map versus hash table. Java hash table. So I'll also share this link which is having good interview question and answers, and I would like you guys to go through it, and if you have any thing which you need to understand, please ask me in the coming up sessions. I don't know why this website is down. This is strange. Okay, good news, it is up. So we'll go to the hash thing, and then we'll try to implement first, then we will understand about what how actually sorting works, and then we'll move ahead. So this is our hash. Now hash, mainly it needs basically you have a key and a value, and then you have to implement one hashing key on what parameter you want to generate, and once that is generated you are able to organize your data properly. So we are going to see this example. Okay, we are good. So what we can do is whenever we are trying to, so this is just a hash map. Now hash map, what it is trying to do, a map has a key and a value. So internally what it's trying to do, it is taking the hash code of whatever the item is there, and it is putting it into so internally the implementation is something like whatever diagram I have shared with you. Internally it does all those things, but we can explicitly or externally do the same. We can implement it on our own. How this thing works, we can just use a map, and then this can be done the way we did the sorting, right? So we can do the hashing on our own. So what we are going to do is we need to overwrite. First let me run this example as is, then we will go ahead. So what it is saying, 3 details, 2 detail, first detail, 103 operating system. So it is trying to do, it is it has put basically 3 books in the map. So we say map dot put, then you have the ID, some kind of so now imagine this concept that array list and map, they are almost same, but in array list you have only option to have the number as the key, which would be your index, and that has to be sequential from 0 to 1 2 3 0 to n. However, in map you can put any key, a string key can also be there. And why map are faster? Because if you have 1000 records in the array, and you have to either, you can directly, if you know the index, you can directly go there, or in this case if you have a string key, for example, I am operating with 5 companies, and whatever data of company A, let's say Pepsi Cola, so I can put the details object here and then can make a string key also. So underlying, they are kind of same, it's just how you're associating. So instead of number you can always have a string. So in our example we will just modify this book, and we will try to make the key as a string, and then what we are going to do is there are author names, so all the books from the same author we will keep it in one bucket, and then we will try to retrieve all the books from the same author from that bucket, and then we'll print something like that on high level. I might leave it half done, and as a assignment you guys might have to complete it. So we will first try to try to generate the hash code. So hash code, I told you before that by default the hash code, let's try to print hash code first. Hash code. Now there is some memory address or pointer which on which this book object is sitting. It points to that, but you can overwrite. It will again sit on the same location. The location might not change. It's just that the default implementation gives you that location, but you can always overwrite it. And override to make it so that it becomes more sense. So in hash table, once it generates the, it gets the hash code based on the items which are in similar place, they will be stored at that place. So let's try to overwrite. And what I am doing right now, it is called as annotation. So annotation helps program to identify stuff and run faster in an optimized way, and it gives instructions, mapping instruction and everything. So we need to do hash code. So I am trying to get the signature. We need to basically get the exact signature. If you don't get exact signature, then it's not overriding. It's called as overloading. Same name but different signature, that way. And you see the native keyword. Native, it has been introduced newly in 7 or 8, like in recent version. So native is a keyword which speaks about if it's a object method or if it's provided by the framework itself. Now it is saying red because in JavaScript it's very flexible. In Java, or even also in Python and other stuff, but in Java, if it is expecting some return type and you are not returning, the program will not even get compiled. So we are going to return, and we can return it based on category ID. Let's say we have a category ID. You know what we can do just to make things faster? We will make this as category, and then here we will define category. We will just skip the author, sorry, publisher. So we don't need publisher. So now what is happening, just try to understand. You have a book object, you have a ID, and then you have this data type, and whatever number of variables comma separated you give, they all get the same data type of string here. And then you are just taking another int as quantity. The another way, shortcut way to do this is same, you can also do, and Java is okay with that. So you have defined ID, you have defined quantity, then you have string. This is your object. Now, so the category, probably we have to make the category as ID, which should be a string basically, int string, something like that. So we will try to make it as, and then whatever is the category, we are going to return the category. So category would be your different subjects. Let's say you have a category called as Java or JavaScript or Hibernate. So there would be different authors which would be writing on the same subject, probably on the same category. Or you can say category as a programming language or a something else. Let's say VSLIs. So in this example, we'll just take category probably as the subject on which the basically category is the programming language on which the author is speaking about. So we'll categorize it in that way, and hash code is going to send the code for the same. Now why is it not compiling? Because we have tweaked the parameters. The parameter we take category over here, probably it was string before, this was the string. So internally we can say that we have category with 101. Look, now it compiles. So to understand, we have category 101 101 for Java, 102 for JavaScript, and 103 for Golang. Okay, so this is cool. Now we'll do our own implementation. We'll try to simulate that implementation. So we need to have, let us see, Yashwant Kanetkar. So first category is Java. So we'll say let us Java. We'll remove these guys. We'll duplicate. We'll say let us go. Let us JavaScript. Let us no, Bible of Golang. Bible of Java. Bible of JavaScript. We can get some more, couple more probably, and then we can say from hero to zero. No, sorry, from zero to hero. From zero to hero in JavaScript. From zero to hero in Java. Author name, it doesn't matter, but what matters is the category, and these are different books. Object, so this is called as object reference. These are because the object class is the book. Once you call the new which will generate another object in the heap, and then whatever you get over here is the object reference. So we are cool with it. Right now the only problem we have is the category. So we have a recheck. JavaScript is 102. So this would be 103. This would be 102. Golang books are 103. Java is 101. JavaScript is 102. JavaScript is 102. Sure. So now we are good. Now, so this would remain same. We'll run the program, and whenever you are trying to do code, just make sure that at every step, whenever you are trying to refactor it, your code should compile and run fine. So this is just the detail of all the books, probably whatever are the books which were put it up in the map before. Now what changes or interesting thing we are trying to learn is we are trying to have simulated hash map. So what you are learning here is not only the hashing, but you are learning the way how you program and how you play around with the code and experiment it to go into the deep dive of this entire stuff. So now we have something which is called as the simulated hash map. So map will have a key and then it would have a list, and that would have a list of books. Just a moment. First, we will try to create a list of book. We will call it as list equal to new array list of book which does not have any size predefined. Then we have two options in key. Let's try to remove this here. So we have a key and a value. So key data type is going to be integer and the value data type is going to be this. Now this guy is good. We have a simulated map. After this you have to call new keyword and then you have to instantiate this same guy. Now again, can you instantiate interface? So map is an interface. It cannot be instantiated. It's an abstract, and interface is 100% abstract. So, oh, it's a this map, right? So what you need to do is whenever you are trying to code, you have to do control click, and then it will take you to the exact whatever the file is there, and that's how you reach. So now you are on map, but you have to pick a implementation. So last class I told always create instance against interface. So this is an interface. You are today are trying taking this implementation. Tomorrow you can change it. Instead of hash map you can make it as spurti map or naren map or whatever map. You can just subclass it, and it would be pretty cool and easy to change, because the whatever methods which are there on interface, they are going to work. It's just that how you are implementing that might get changed. So now you have got the simulated map. Now inside map, before putting it into the map, you have to create the list of the categorized item. So we have a list of books. So we have the list of Java books, and we are trying to learn implicit way how Java works. All this exercise, what we are trying to do here. You have list, you have three list of books. Now you have to just grab these books and put them there. Let's try to divide it. So whatever are the Java books, you are going to put it in the list of Java. So either you can do it this way, that first you get the object reference then add it, or you can simply put it in directly inside it, and we'll learn both ways, no worries. So first let's try to put java dot add, and then we have book 1. So we have 3 books of this. Now we'll go with JavaScript. And last is Go. So until and unless your object reference is not used, it becomes discolored. But as soon as you use it, the IDE tells you that it has been used. Because Java has garbage collector, so if you create the instance and you don't use it, implicitly it cleans up the memory at the runtime. And so this guy JavaScript just has 2 books. So now we'll go with the list of JavaScript. You have B3, and then you have B6, and then since this guy has less book, you can add book directly. So you will say, okay, I need a book which is, it can have any code or whatever, we are not bothered about it, but let's give it 420 as code, and then we can name it as what name. Can you please suggest some name for JavaScript book which you might have read? Let's go with,
Allocate.
sorry, which one?
Allocate.
Al- allocate.
Allocate.
Allocate. Okay.
Yeah.
Okay. So we'll name it as allocate. ALLOCATE. Allocate JavaScript. And then we have the author. And then we have the code category ID. And then this could be anything. Cool. So what we learned here, either you create the object instance directly, so whatever the object reference, it would get added. It's the same thing, you do it first, create this way or this way. But so when you do this way and this way, this is something to be learned. So if you have to use b3 again, if you have to modify it or need object reference for this, then you go with this way, because you get another pointer which consumes some memory. But if you don't have to use b3 object reference anywhere in the program, then this is the best way, that you directly create it and put it in the list. You can retrieve it because you don't need the b3 anymore after this. So that's just a best practice, but for readability purpose, usually people might create this initially, but when performance purpose comes up, then they will try to avoid the intermediate object reference, storing in some object reference, because this is additional storage which is just using once in the entire program and nowhere. So we can optimize it. Now let's try to have the list for C. What we named it here, go. Yeah, sorry, go. List go lengths dot add. We have b2, b4 and b7. That's good. So this program, for now we might not need it. It's just reading and other stuff in their map. So I'm going to comment it out. I'm going to push it. So once you do it, first you uncomment it, run this, and then you go with this implementation. Now comes the real simulation of the hashing, how hashing really works. So you have a simulated map. Now inside the simulated map, you are going to put, now there is a hash code for the all these books basically. So you are going to put first key is 101, and then you are going to put the 101 inside the Java list. Same thing, you have a hash map, you are having this. So now imagine that these were all your 1000 students and there was no sections. So you created section as these simple sections. Now you are trying to name the section. So your section 101, section 102, 103. So if you need anything, you just call it and then you will get whatever people are in that section. So you just iterate on that. That's how they also operate country. America is very big, but they created small states. So first they figure out in which state. Now once they go to state, then they search instead of started and doing the search on entire stuff. So now thing comes of retrieving or printing. So we have to retrieve anything from it. So first we will do simulated map dot get. I need something from 101. So this is what we are going to get. Now we are going to of course get a list of book as a return type of this. So we are going to get a list of book. Now once we get the return book of list, now we can reuse this. So we have an integer value and then we have the book. Actually, you know what? We have a list. So this is not a good stuff. We can just do an enhanced for. So how it works is you have the colon, and colon separates two things. First is your list name and second is your um object type. So this should be good. Now if we try to print it, it would make more sense. So this way you got all only the Java books, and same thing you can do if you will try to repeat this. I have to tell you something about scope. I'll just tell you. So why it is giving trouble? Because you have already created one variable with the same name. So it is having trouble. So there are two ways to solve. One is you make it something else which is good. but it's again not optimized. Basically, when you talk about a programmer versus a good programmer, so since the object was already created in the memory, and you are not we are not planning to reuse it again, so you can use the same object reference. It will be initialized with other values, so this will be used again, reused without a problem. Now the B, this is having a scope. Scope means here. So you will wonder that since B was already defined above, then why compiler was not having problem here when it was used here. And the reason is, since this guy is having the block scope of the for loop, as it came out of the for loop, its scope died down. So you can now create more variables inside other, or maybe here as well. And this guy will technically, since scope is not clashing, just imagine this was never there, the scope was not clashing, so it allowed you. But as soon as the scope clashes, it will say, boss, B has already been defined somewhere in the, let's try to read. Variable B has already been defined in scope. So this is called as scope. If it is not in scope, you can always do it. So this is good thing about Java. That's why it is better than other languages. Especially JavaScript has a lot of memory leak, because you can create any variable without even realizing what's the funda of scope. And scope is something, whenever you're trying to create one variable in Angular, I'll let you know about how the problem of the scope in JavaScript, they try to solve it into the Angular JS framework when they implement it. But the basic concept to understand here is, you have to scope something so that it gets garbage cleaned or cleaned up as soon as its scope gets finished, so you get more efficient program. Otherwise your program is more like a garbage program in terms of memory. It's easy for the programmer to program. He don't have to understand these concepts, and he will write any crappy code and it will work. I am not saying condemning other languages, but JavaScript and Python are something like that, which are more programmer friendly, but they are not machine friendly or computer friendly. So they have lot of memory hogging. They do not perform or scale well. So that is why Java has been, or the Golang is just in similar terms of Java, combination of Java or C, something like that. So it also performs well. So now we will pick all the values from our next category, and we are going to do the same stuff here. Just to create gap, we will say system dot out dot println, and we can leave it empty, because since it was connected, it was not showing up properly. That is why we did it. So we are focusing more on the name. Just a moment.
Yeah, so I think it is printing the previous values only, like with ID 101.
Yeah, that is what I am trying to figure out. In simulated map, when we say we want 102, right? So we'll just figure it out. So 102, where is our simulated map? Just a moment, where we are putting this. Okay, so the problem is not with that. The problem is here we did a typo, so we have to correct here. In
Yeah,
102,
yeah,
it
yeah.
retrieved the good bucket, but we have to, 102 was for what? 102 was for JavaScript. So where is the JavaScript list? This is the JavaScript list. So we will now have to put it here in the JavaScript, and this would be a go list. I hope this would work as expected this time. Yeah, and it did. So it was able to do it in a more efficient way this time. Same thing we are going to do now with the system.out.println. There is a new line character, so I'll just let you know what is that. So instead of doing system.println, you can also do, I don't remember if this is forward slash or backslash. We'll just figure that out. So this should be the other way around. Oops. Yeah, it was. So this is called as the new line character, the slash n. So they have different characters in Java. So why and when they are used is this is again which is called as the formatting or escape sequence, and you will read it with some other names. So for example, you want your ID in the first line, and then you want rest information should be printed in the next line. Inside here, you can put something like this. See, so this is your ID and this is your value, kind of. So slash n will help you in doing the proper formatted when you're trying to log it or when you're trying to see it in the console or whatever. So for now, I just remove. It depends on your creativity. Whenever you will do your projects or whatever, just try to use slash n and make this formatted properly. So this is one part of the code. Let me first push it up till this, and then we'll just make minor modification and we'll move ahead. Oops, there are so many stuff. But I am going to push this first. And one more request for you guys, whatever thing you understand or read in future also, when I'll not be your instructor anymore, probably after a month or whatever time, but try to simulate all the concept and implement it with hands-on, because you see and read it's good, but do a hands-on, and then it will give you more and more depth inside it in terms of understanding, because you are implementing what other programmers are using, you are trying to implement it, the same concept, and that gives you an extra edge. So simult simulated hash map or simulated hashing algorithm. Now we'll try to optimize this. So there is one trouble. If push got rejected, master was rejected. Manually, I might have to do it. I'll push it. Right now, it got committed. So instead of adding it manually and segregating it in list, 2 or 3 list, it is good. That's not a problem. But further, can we automate this so that if there are 100 lists, we don't have to manually do this stuff? So yes, there could be a way. And what could be the way? Just understand. So you are having the book, and once you are having the book, you want it to get added in uh, some or the other bucket, or some or the other list, basically whatever is the list. So which list it should get added to, that is you want to know. So what you can do based on the hash code, whatever hash code it is get you are having, you just put it in that. So we will try to learn this. The next advanced step is you have a book and then you have a hash code. So you get a hash code, then you have a map, you have a simulated map. So what you are going to do is you will have your simulated map. Now inside the map you will try and you will say wherever the uh, this book will go to the bucket, whatever the hash code it comes. and we already know that we are returning the hash code of the category. So what we are trying to do manually over here, that we are trying to automate it. So it might get completed or we might get stuck, so we might finish it tomorrow. Basically, we'll not spend much time, but we'll give it some 5 or 10 minutes to automate this entire stuff. So you have got this guy. Now you need to get a list basically, and whatever the list which is equivalent to this guy, inside it the value should get added. That is what you need, right? So you have a list. Inside this list it should get added. So okay, there is another way. Now you need to get the list and add it inside the list. So how you would get the list is, you would say this dot get this, and then add, you would say b1. Let's try to break it down further. So here you are required to have a list. Let's take small steps. So you will be having a list of books technically, and how you would get that is you will get it from the simulated map dot get. You will have some hash code. Once you get hold of this list, you are going to add the value of that book inside it. So if I am going to run it, it might get blown up. So first we have to initialize this with different lists based on the category. So what we are going to do is, and it might take time for probably for you guys to understand. Once it will run everything, I'll just repeat and go through the flow again what we did, and then it will make things easier and cool for you. So we are going to put what? We are going to put 101, 102, 103. Inside this we are going to put three different lists. So first list would be for Java. Second list would be for, why is it crying? Wrong first argument type. Oh yeah, cool. So we have simulated map. Inside the map we have got these three objects created. After we got this, now we have different books. Whatever books we are trying to create basically here, we are trying to add it in the simulated map, and it will automatically take care of which item it has to go in. based on whatever book. So what I did over here is previously we were getting a list, whatever is the respective list or the bucket in that category, and then we were trying to add the book inside it. Now we don't need the temporary variable, so I put entire thing in this single line. If it makes sense, if it is getting more high level, we can just simplify it in this way. That is fine. Otherwise, I just try to do more optimization. Let's go with the simple. So we are trying to get a particular the list in from this simulated map. So the book will give us the hash code. Once we get the hash code, we will try to get the same value in from the map, and once we get that particular list, we are trying to add that book here. So we do not have to decide in which category that book will go, something like that. So now I am doing this first. We are not trying to add anything manually. We have got the automated way of doing this. Now we'll try to print it. If it gets anytime, a little bit high level, just stop me there. That is fine. So right now we only have one list here, because what we asked now, book is taking care of itself. That book knows which category and how it needs to go. That is why whatever the redundant code we have written each place, that is not required anymore. So if you guys allow me, I can use this simplified version instead of this. I hope you might have understand. So I will add it because I want to save some memory and some process. Okay, so this single line will take care of entire stuff. So now what we are going to do is, we have the B1. Now all the books would get added. So before adding these books, I will just go with the JavaScript book, one book. And then I just want to show you that this works across everywhere. So the code will be smaller and it would be more effective. So now we have got another book of JavaScript also. So whenever we are trying to create a book object, at the same time we are telling the book to find out which list, which bucket, which hashing and everything. So it figures out, so you don't have to write and do entire code manually. That is automated. This is called as dynamism, where you have very less programming to do, and program is smart enough to find out everything on its own. Now we are trying to feed everything and we don't have to decide. Program will get the hash code. Based on the hash code, it will get the category. Once it get the category, it will retrieve the list from the category itself by this, and once it's get that, it will add it automatically upon it. So you don't have to do anything of this. You're just calling this method basically, and method is automizing the stuff. So on the very first day, as I told you, same result, same. There is no difference in result. Only difference is in the programming approach or the performance. This is less headache. The code looks clean. The code looks short. Let's try to run. Now we should technically see all the books from all the categories. They got saved automatically inside it and they got retrieved also automatically. So we have Java, we have JavaScript, we have this also. We don't need to print this creates confusion because we already have the ID. Now I'm giving you a task. So I have automized this stuff of inserting, right? Can you automate the print? So we don't want this thing to be repeated. Is there any way that we can just write small line of code 3 4 and this program should be efficient enough to figure out the what category book belongs to, and based on that it should print, like based on which it retrieved. So if you will see the previous code, it was bulky and huge. Now the code is just simple. You have initialized these guys here, and then you're smartly, and we are doing a lot of stuff. If when we started the class, if you will see the hash algorithm, it was, oh, what is happening and whatever stuff. Now when we implemented it, it came out to be pretty super simple. Here within these lines of code everything has been done because we have optimized it. Now this is looking bit bigger, so please optimize it as a homework and try to have one loop which should be able to figure out all the books from different categories and should be able to print it up. That is your homework assignment. So I am trying to run it and then push it up. Then we'll move ahead. And once you print, please try to print gap or something. Whatever way you can format it better, just try to do that. So before going here, let me make the change in one file only, hashing. Spurti Naren, anything were you able to get the concept, high level concept?
Yes, sir.
Yeah, yes, sir.
Okay. So please push that in your folder. Take this entire file and then try to push that and try your best. If you're not you would be able to do it. If you are not, then in tomorrow's class we will take that as first. We'll understand and then we'll do generic printing for every stuff. Let me at another all other files, then we'll move on. Git add dot will take whatever is there, it will add everything. You have git add all. Now you have to do git commit. Minus m gives the message. Git commit minus m collection related files. Now you have to do git push origin origin master. Wait. So this might require a pull. I'm not sure, but let's try to do that first. Look, it has given the hint of taking pull. And same thing, why it happened that my head was not in sync. So in the Git repository, there could be some changes which might have impacted the same file which I am working. So Git is not sure what has changed there. But Git is sure that my version is not latest or latest enough, good enough. So it cannot push it. And then when it tried to push, it says there is some mismatch in the head is down. So now it is requesting me to pull the code, and if it will automatically merge. If there are different files, it will automatically merge. If it is on the same file, it will try to merge it, but if it is on the same file and same line number, then it would give us the git conflict. So I don't think we will end up having any git conflict, because Purti and other guys have their own files, and I have made changes in some other files. So now it is saying that it was able to do everything fine. It merge made by the, and this thing is called as strategy, recursive strategy. Like we just understand a strategy of hashing, hash coding, adding dynamically and everything. Same way it has some internal algorithm or a strategy which is recursive. So now the push has to be successful. We will validate it from the cloud itself. Wait. Cool. So let's go to cloud. Let's go to the commits. 1 minute ago. This was the merge, collection related files, optimized hashing, simulated hashing. So if you have to, for your homework, you will be doing raising a pull request, right? So this is a separate, directly you can click on the hash code. So this guy also works on the Git also works on object hashing. So what you see is a hash code. Look here. This is called as a hash code, this guy. So if you are trying to click here, if you are trying to click here, you will get this code. Wait, this, both are same, but this was the lengthy version, right? And you can then go to view, go to raw, do a control C, put it on your browser, whatever IDE, and then make changes, submit your homework after making changes in the display. So now coming back to the need for the sorting and what Java framework has to offer to us. So wherever you go online shopping, you get the option sort by price, sort by name, sort by category, sort by this, sort by that, what sort by the number of reviews, whatever. So sorting is in general very important, and there are several strategies for doing the sort. Now underlying their bubble sort, and I don't know, there are so many sorting in college books. When I was doing masters about 10-15 years ago, there were so many, but Java framework has already implemented the whatever is the best sorting implicitly. So we have to professionally, instead of reinventing the wheel, we have to try out and abide by it, how we can leverage upon it. So once there is better strategy which will come in the market after 3 years, you don't have to rewrite entire thing. The new version of Java, if you have used their sorting, it will already taken care inside it. You whatever the code you. So sometime we might have to leverage upon it. So we can sort the element of string objects, wrapper class, user defined class objects. Collections is a class provides static method for sorting. Static means I already told that day that you don't have to create the object and then after object reference you have to consume it. Once the utility method, they are made as static, so you can do class name dot and whatever is the static method that can be called upon. So that's how usually the utility methods uh, until, because methods do not want to keep the state, they just have the behavior. So there is the concept that when a class which only has the behavior, then it makes sense to make it static. Interviewer will ask, when do you want to make your method as a static versus when not. So when you have to, when a method is uh, part of the class which has some state and the behavior, or the behavior depends on the state. Now giving you an example, you have to calculate the result of a student. Now student have some marks, so there is a student class and there are some different state of the variable. Let's say marks in maths, marks in science, and marks in other subject. So you will set, okay, student dot getter, there would be getter for maths, and then you will set the, sorry, you will set marks for maths, and then you will set the number. So that particular object will have its own internal variable which will have the value, and then you will call the method get result or calculate percentage. So it will add up all the subject, divide it, aggregate it, and give you number. So that method, it doesn't make sense to make it static, because the class is having some variable, and there are 10 students, so 10 student will have all different states of their state, what we say as value of their variables, and their method will yield everything different. But when we come to the utility method, that time the utility is something generic or common. So you can write a utility as a display in formatted way. So you just pass any student, and whatever the values are there, it will just format it and print it. So these method do not have these class, util class, they do not hold variable state, they only have the behavior, they do not have the state. Maybe it might sound a little bit high, but just you will realize it once you will do more programming in any language, you will realize that. So collection class provides static method for sorting the elements of collection. If collection element are of set type, we can use tree set, but we cannot sort the element of list.collections. Class provides method for sorting the element of list type elements. Method of collection class for sorting list elements. So it is giving you a list, is used to sort the element of list.list element must be of comparable type. Comparable means you have student, and how do you want to compare? You need this program to be understood, right? So student, you can say, okay, the person who has more age is bigger, and rest all is small. So there is a criteria of +1, -1, and 0. So if the difference between the age of two people is 0, then they are equal. If it is bigger, then it would be 1, so you denote it by +1, and -1 is if it is lesser. So there are three criteria: either it could be equal or greater than or less than. So these are the three criteria on which you sort or compare. So now let's go next. So we have a public void sort method which consumes the list, is used to sort the list. So string class and the wrapper class implement the comparable interface. So string has the implicit class, and wrapper classes are integer integer, not the int. Int is a data type, and integer is a wrapper class. So float, whatever like string, they have implicitly the comparable interface. So if you store objects, it would get compared automatically, and then it will sort it automatically. We have seen this example before. We'll real quick look it here on the browser itself to save some time. So we see it is getting sorted, and it know implicitly that criteria is for string would be alphabets. So I want to tell you one thing. Here I will ask, you both have to answer. So Asim A White came up, and this was also Asim White came last.
I think it depends on ANSI code.
Absolutely. You are pass, you are selected. Yes, Purti, you want to say something?
Yeah, that is the same. I wanted to say
Sure.
it
So
depends on the code which given by ANSI code values.
So what happens is, I think 65 is for the capital. So first the NC code for this guy, capital letter comes and then the small letter comes up, the NC code. So that's how the sorting internally works for this. This is number. So what they are trying to do here is they are doing integer dot value of. Integer is a wrapper class. If it is just 201, then you have to wrap it up. If you want, we can just try it also. So it is saying, oh, it also did the same thing, what I wanted to tell you. So it says internally it will be converted to convert the object as internal, sorry, integer dot value of. So value of is the method and this is called as auto boxing. So the concept of auto boxing is either you convert it explicitly by doing this. If you don't do this, it is internally doing the same thing. So they called it as auto boxing, automatically boxing. It in Java 5 version 1.5, whatever the 5 right now it's 8 or 9, whatever it's 8. In 5 you have to always do it explicit. If you don't do it, you will get the compilation or runtime errors. So this is the concept of the auto boxing. So let's try to close this and let's try to move ahead. So comparable interface. Java comparable interface is used to order the objects of user-defined class. The interface is found in java.lang.package. So package varies because there could be several other interfaces with the same name. But what matters it in your Java class, what package you really import? Is it java.premasim dot comparable or is it java.lang dot whatever that would be used, and contain only one member method called as compare to. So the beauty of this interface is it only has one method which is called as compare to. It provides single sorting sequence only. Single sorting means you cannot um, here it goes. You have student with Asim Jain and Asim Sharma. So if you will try to do sort on first name, so you will just get the sorting on first name itself. If there are two person with the same name Asim, then you want, okay, if they have same name, then let's try to do the sort on the second name. If they have the same first name, there would be coincident. Rahul is a very common name. So Rahul Gupta, there are three Rahul Gupta in college, 1,000 people. So whosoever has more age, the sorting should happen on that. So that is called as secondary or ternary sorting. So this guy provides single sorting sequence only. You can sort the element on the based on single data member only. For example, it may be roll number or name or age or anything else. So in interview, basically they ask when to use comparable and when to use comparator. If both are doing the comparison, then you have to say that comparable does it relies only one attribute or one field at a time. So this is a compare to, and then it takes the generic object. That's how the method signature is. So you will say public int compare to object is used to compare the current object with the specified object. We can sort the elements of string objects wrapper. Okay, this we already learned. Now we have collection class. Collection class provides static method of sorting the elements of collections. If collection elements are of set or map, we can use tree set or tree map, but we can sort elements of list. Collection class provide method for sorting the elements of list type. Method of collection class for sorting list element is public void sort. So this method, whenever you call and pass it a list, is used to sort the element of the list. List element must be comparable type. So if you have a student and if you don't have this implementing this guy, then forget about sorting it by the help of Java framework. So we will now try to run it actually on our machine. Let me make a folder. I'm just trying to organize my code separately, otherwise it gets mixed up. So this package would be comparable. Comparable. Now comparable has two things. First is the student class and second is the main program. Main program. So we can name it as a client. I usually name whatever my main you can come up with your own conventions, but I have this. So people know, okay, this is the client. Client means whosoever is using the user program. So client will call the actual method or util method or the program. So I call it client. So we have client.java. You can call it as main.java as well. Since I do not have any imports, it is giving trouble. So student, we anyways don't have it, so it is going to cry. That is okay. So now we will try to create student. This I have to repeat again for you. I'll repeat again. +1, -1 or 0. Now this will not cry because it got everything over here. So it has got the student and then it has got the comparison. For example, if we don't implement this and it already has this method, but this collection will not take up because it takes collections has a sort method which takes the list, but the list has a compulsion that it should implement comparable interface. If it is having comparable interface, then only it will do the comparison. So internally when it sorts, it is going to this student and the n+1 student in the list what we implemented the first day in the sorting. So the n+1 student, it will check. So this is, let's say, Naren, and we are comparing Spurti and Mohan and Asim after that. So first we'll compare Spurti with Naren and say age difference. If age is more, let's say both have same age, then it would return 0. If Spurti is more, like this object, whatever is more, then it will return a +1 and then -1. Based on that, the element might travel up or might travel down. And this is how it gives the number for all of these stuff. Now try to run it. So it has given this. We'll just try to play around with it a little bit. So you are trying to do the comparison based on the age. So for example, you have to do the reverse sort, whatever is happening now. So what you can do is you can just convert it. So now this order would be reversed. So this has been reversed. It takes positive value, it takes negative value, it takes everything basically. And if you make it equal, let's see what happens. You can make everything equal. So now whatever way you are trying to insert, that would remain same, because whenever it is comparing, it is always getting it's not getting what it is supposed to get. So this is not the problem of the framework. There are some stupid programmers which would not implement the method on their side. Whenever they implement the interface, they implement it incorrectly, and then they say, I'm trying to sort it, but I'm not getting the expected result.
Hello, Ji.
Yes,
Yeah, could you please explain me how exactly compare to works means how the student object ST will compare with other will get compared with other three objects and all stuff.
sure. So what is happening in the list? We have two for loops. Let us try to open our my sort. So we have two loops, right? So first loop, the first element, let's say go in the nested loop. So whatever element we get from here, we are trying to do the comparison it with some all other students. Let's say this was the first student. So it will compare with this, then this, everything. So if it is heavier, it will move down. If it is not heavier, then it would remain same. So this is the same guy. Now when we try to see here in the student class, so whenever you are trying to call each student, so first it will take the first student, and then it will do the compare to all the other students. There are how many students? Five. So first it will just take one student and it will compare with all five, all four basically. Then it will take another, and then it will compare same with this and same with
Yeah,
this.
yeah, I got it.
Fine. So this
And
method,
could you
this
please say me what does return zero like difference between return zero and minus one?
okay. So what happens is, first let's take example of Vijay. So Vijay, first it will call Vijay, and then it will try to pass all other objects, compare Vijay with Ajay, Jay and Asim. So once it compares with, so when you say Uh, so there are two ways. First is age and first is student dot age. So the age belongs to this student. So first if we take Vijay, so this age belongs to Vijay. And the second, whatever is the parameterized, we call it as student dot age. So second could be Ajay. So then this is the age of Ajay. If both are same, it will return 0. If Vijay is greater than the other student Ajay, then it will return other way. Yeah, I think I swapped it, but if this age is greater than this, then it will return 1, otherwise it will return -1. So this is the algorithm. Next iteration, it will come, the this student will remain same, the first Vijay will remain same. That way it will compare with Jay, and then it will compare with Asim. Based on that, internally Java understands that among all the students, Vijay's position is where. Vijay is, based on this comparison, and then it puts it in the structure. Second time, it will pick up another student. Based on the another student, the value would remain here for this student and all others. So if we are talking about Ajay, it will compare Ajay with again all the elements Vijay, Jay, and Asim. But somehow it keeps track that if Ajay and Vijay's comparison has happened before, it will try to avoid it, comparing it again, so that it can get the performance benefit. What we were trying here, my sort algorithm, yeah, here. So what I did is every time we are trying to compare it with one less person because it has been compared. If even if you do a dot size, the result would be same. We proved it that day that this is going to be the same, but there would be more iteration. So we can try to avoid it. So that's how this works. Any more explanation, or is it clear now?
It's clear now.
Okay, cool. So I'll just push this. I'll first run it before pushing. Let's try to run this again. Yes, so it is working as expected. I'll just make this value as positive. So the main thing with comparable interface is it goes to that particular object and then it compares it with all other objects. And then internally it keeps track the student lies in which category. Instead of age, you can do it on marks or whatever because one interface has one method. So there are on you cannot compare it on two elements or whatever. So when there is a problem, when you have to do secondary sort, then Java has provided other interface basically. So we are going to learn about that. First we will push this. So the push was successful because our head was properly here. So comparable and comparator. We will have a client for this. So comparator interface, Java comparator interface is used to order the object of user-defined class. The interface is found in java.util and contains two methods. First is compare to, which is having object 1 and object 2. So in the past example we saw there is something called as this and then the other guest object. So let's try to go here. And here you can call it as this means this whatever the object and other object is the guest object. So this object is compared it with the other objects. However, once we go here, this object does not compare anything. It's a third party object which will compare two objects. So it is the just take the example that in a class when students are trying to say, hey guys, just compare your height by yourself and stand in a line height wise. So you guys are technically trying to do the implementation with comparable. But once say, okay, teacher is coming and he will measure each one of you and then he will give you the result. That means some third party person is coming and doing it for you, then it becomes comparator. So this analogy would be clear once you go ahead. So I am comparing, first I am taking Spurti's height, then I am taking Naren's height, and I am giving the result. I am the third party guy who is taking two students in all by himself. Then the comparator. Let's try go and then I can repeat this. It might make more sense. So it gives you the interface is found in here and contains two methods. One is compare and second is equals. It provides multiple sorting sequence. it can sort the element on basis of any data member, for example roll number, name, age, and whatever. So in first sorting, if there are two things which are similar, then you can fall back on second, and then you can fall back on third, something like that. If two people have same age, then you have to go with the roll number, whose roll number is smaller, that would be shown up first. So there is something which is called as compare method. Compare method takes two parameters, which is these two parameters, the first object and the second object. It will compare. Now collection class provides static method for sorting the element of collection. If collection element are of set or map, we can use tree map or tree set, but we cannot sort the elements of list. Collection class provides methods for sorting the elements of the list type elements also. Method of collections class for sorting list elements. So you have this, you will pass the list and then you will pass the comparator. So another difference is, if we'll go here, you found that we had to do nothing. We just had to say collections dot sort and everything was done automatically, because the comparison algorithm or logic was defined in the object itself. Now we will try to implement compare third party stuff, which is the algorithm will not be inside the student, it would lie somewhere outside. We'll see more. Java comparator example, non-generic old style. Let's see the example of sorting the element of the list on the basis of age and name in the first example. Student age comparator, name comparator, and simple.java. So we have the student class already there. Now we have to have another thing which is called as age comparator, which is third party. You can think of it as a teacher. So I am the teacher, you can call me age comparator. And I am now, instead of previously student were figuring out their own age, now I'll be figuring out your age. This class define comparison logic based on the age. If age of first object is greater than second, we are returning positive value. It can be any one, such as 1, 2, or 10, etc. If age of first object is less than the second object, we are returning negative value. It can be any negative value. Let's not read this entire thing. Let's try to do hands-on practical. That will give more sense. So this is crying because it does not have the proper import. Now it has got the import. So we have got two objects and this is called as casting. So every class is an object. So if you pass any object here, it would be taken up. But object does not have a what you called as age, because object does not have attribute. So just to call that, you have to cast it. I'll clear your this concept first. So this O1 is a object. You can always call it as S1. So this does not have any age basically, right? Because this is the object type. In object reference type, it does not have that thing at all. So you have to explicitly say, boss, this follows object, but this is of kind student, and student has a age. So student has a age, or if you click here, student has a age. But in object it didn't had, so it was not. Now previously in this example you were calling this, where it has, yeah, this. So the student was comparing itself with other student. This student was comparing with the other student. Here teacher is comparing between two students, student 1 and student 2. So the comparison remains same. If on he has got two, O1 student 1 on the left hand side, if both are equal, it would be this. If student 1 is greater than 2, then it will return plus 1. plus 1 or any plus number basically which is greater than 0. If you say plus 100 or plus 10 or whatever, the only thing is comparison, that it will give some greater value which is greater than 0 and less. Here it would be little bit less. So this is how the implementation happens. We can try this. So we have to follow the convention basically, how it is, how it will consume this. So you have the same stuff here. You have to say new comparator, whatever the object you have created, you just have to say new keyword. Now this is good. So result would be same, but this thing is different. The implementation is different. So I'll first run this and then we will try to change the comparator. Now if you implement comparable interface, you are stuck with only whatever is implemented here. It could be age or something. If you have to sort it by marks basically, then you have to re-implement this and then this would go away. But in the comparator interface you have the option of multiple. So in single way usually no one will do more than one sorting usually, like for example the price or whatever. But on the domain object, which are the core object, but there are few objects on which multiple comparison is required, you can create as many as you want. So we will try to write another comparator. Generic means you can avoid typecasting. So I'll also first show you this guy, so show you guys this, then we will try other. So if you pass it as student, then your problem would be solved here. Then you do not need this casting. This will run fine. Run. So again same result, different implementation. This takes up less memory for the computer system because you are not casting it, you are not creating any temp variable or whatever. So a programmer versus a good programmer, that's all. Performance. So this we learned generics. Now we are trying to compare the we are trying to do a name comparator. So we have generic, we have a name comparator, we have two students. So in Java, they for the string they already have a compare to method implemented. If you go here in the algorithm, it will try to figure out basically in some way. You will just read it in detail. Then it has some way to compare the two strings, and whatever is the bigger string, that way it will get sorted out. So let's try to see. Asim is coming last. Ajay. This is all in different sequence. So we will try to, either we can do double. That is fine. We can do double. So first you are trying to do age comparison and then you are trying to do name comparison with comparator. So first the result is sorted in. Sorry, I didn't put the space. Sorry, I forgot. So first you did the comparison on the basis of age, then you did on the name. So from the UI, whatever UI you guys are generating for Walmart or whatever, you will give the sorting option Once someone clicks on the name, then in the backend you will call this comparator. There will be some if condition. If from UI, if a client wants to sort it by name, then you pass in this comparator and this will do the stuff. Otherwise you will do the age comparator. Or if you will not do anything, then by default the comparison will happen on this. So even if you will remove this, for example, the things will be sorted by default. So the first thing is another interview question. Comparable is defined to provide the default sorting. Look, the result will remain same. This guy, just observe, keep an eye. So the result are the same. This is getting sorted by the age. So default comparison would be on age. Second case, you did the comparison on the name. So in UI, you can implement several fields for the product, number of review, blah, blah, blah. Based on that, you will call different comparators, whatever you have to implement it, third party comparators. But by default, when page is loading first time, it has to sort in some order when user has not given anything. So the default order on which the student that instruction would be given from this compare to method. So this is pretty much it. Basically, we have understood very fundamental, very basic concepts of all these things. So now I would expect tomorrow we can start by 10. We'll go couple of our sessions, and then we'll understand about threading. What is thread? How are the ways we can generate threads? What is marker interface and other stuff like that. So I would expect and I would feel good if you guys can implement comparable comparator, can do the hash code, so your own hash algorithm displaying the values in an optimized way. Finish this entire collection thing, and then I can teach you with more interest tomorrow if you will finish your homeworks properly. And any questions now? uh,
No, sir.
Fine. Okay, guys, enjoy. So, see you at 10, and we'll start first from your pull request. First, from your pull request, and go through interview question answers. And whenever you have anything related to this collection stuff, we will first address those question answers and queries. And I will again stress hands-on, because other teachers they'll go more on theory, and it is good for them, whatever it's temporary stuff, but I press more on hands-on, because then your brain and your fingers and everything will work in coordination and concept is clear. So if you lose this language, you pick up any other language, you have the concept in your brain and muscle memory, right? You have actually implemented it. So in long run it is good, in short run it is bad. In short run, if I'll teach you through PowerPoint presentation and theory book and all that, you might do better in the instant interviews, but after some time you will forget and you don't know the fundamentals. So it's not good for you. Good for me, probably. Okay, I covered everything, all the theory, but I'll speak up more so that theory is covered and the concept, but then I press on more hands on. So do more and more hands on right now in this repository, and after that you create your own repository you already have created in GitHub, or whatever you learn, try to even do a small program, but try to do it and push it. Fine. Okay, let me just close this recording. Then I'll send you guys the entire detail with the homework, whatever homework I have just spoken of. And we'll see you tomorrow. Fine. Okay, guys. Bye.